The next thing we're going to talk about is something called finish flags. The idea is pretty straightforward. There are a lot of processes out there that have to be controlled by a PLC, where the PLC does the same thing over and over and over again. Think about an injection molding machine. What does it do? Well, it sits there and runs all day, and as long as there's plastic in the hopper and electricity to heat up the barrel, what it really needs to do is bring in plastic, close the mold, make sure the mold's up to temperature, squirt plastic into the mold, wait a certain amount of time, or include cooling to cool the part down quickly so the mold can be opened up and cycled quickly. Get the part out, close the mold again, maybe do some checks along the way, some automatic checks, and shoot at the next load of plastic. So it does this over and over and over again. And of course that would be a very boring task for a human being, to push a button to close the mold, push a button to inject plastic, push a button to run water through the mold so that it cools down. This would be a very boring job, and a PLC is ideally suited to doing things over and over. You can think of this as sort of like a recipe, or like your washing machine. If you look at your washing machine, you probably have several different settings for delicates, for hand wash cycle maybe, or a normal or a very soiled load. And the recipe is different between them depending on how much time the agitator moves the clothes around, how much water goes into the tank, depends on your setting. But basically the recipe is put water in, release detergent unless it's the type where you just pour the detergent in directly, agitate for a certain amount of time, maybe rinse, maybe add more water, agitate again. So there's different recipes depending on exactly which one you choose and what you want to have done to your clothes. But understand, it follows a sequence. It's kind of like a music box. If you've ever taken a music box apart and you see the little drums with the pegs sticking out of it that pluck the musical tines as it goes around, the recipe on that drum is the song, right? It's which tines need to be played at what point. So in the same way, we'd like to make something like that for PLCs. We'd like to make a program in the PLC that operates the system in a particular order. So to start off with, we're going to look at this particular simulator. It's the batch, I think they call it, what do they call it? Let's see, yeah, batch simulator is all they call it. And the first thing I'm going to do is introduce you to the simulator, but then we'll program it and we'll come up with our own recipe. I haven't looked in the student exercises or anything to decide exactly what I want to do, but let's just pretend that this is a chemical process. We're mixing two different chemicals out of pump 1 and pump 2, and what we want to do is just fill a certain ratio. Let's just, I don't know, we'll make it 2 to 1 or something like that. We want to mix it up for a little while, so a certain amount of time, turn on the heater afterward. Once it comes up to temperature, maybe do another mix, and then pump the product out, assuming that that's all we need to do to it. So along the way, I want to use the various sensors and output devices in the simulator. And so I'll show you, I've written a small program here just to show you what everything does, and so I can figure it out too. So let's download this. Oops, I forgot I already had it in run mode. And let's run it. Now I've wired things up simply. I just want the start button when I press it. I just want it to turn on the pump so that I can see if that works or not. Same thing with the stop button. When I press it, now be careful, the stop button is closed right now, right? So what I want to do is invert that signal so that when I press the button and it's not making power, that's when I want power passed to the pump, because when I press the button in, I want the pump to run. So I have this inverting instruction here because the stop button is normally closed. That doesn't mean that's what I would always want, okay? It's just in this case, I want the pump to run when the switch is activated, and activated means it's not passing power. All right, so I've also wired up an enter button here in order to pump the mixture out of the tank. There's a flow meter on pump 1, so I'm not sure exactly how this works. I haven't tried it yet. We're going to find out. I think what it'll do is give me pulses. I think it's supposed to be like a, what do they call it, a paddle wheel flow meter. And basically a paddle wheel flow meter gives you ticks as it goes around, so it ticks off volumes of fluid basically, and if you count those ticks, you know how much fluid has gone by. We'll actually have to experiment with that a little bit to figure out how many ticks represents a full tank. But Anyway, I've got that set up for flow meter 2 and flow meter 3 as well, and all I've done is wire them to the lamps so that when I turn on the pump and the flow meter starts turning, maybe I'll see the light flash or something. I don't know, we'll see. And then I've got the selector switch. Now the way the selector switch works is kind of interesting. If you hover over it, right now we're in position A. And so you see that position A is input 1/9. Now if I move it to position B, what will happen, that little note will come up and it'll say position B is input 1/10 and C is 1/11. So I've used 1/10 and 1/11, but not 1/9 because I want a place to basically not do anything. So 1/10, if I move the selector switch to B, the mixer will turn on, which is right over here, this mixer in the tank. And then if I turn it to C, then the heater will come on. So let's play with this and see what happens. I guess first of all, let's just turn on the heater, and it doesn't do anything. There's nothing in the tank. Of course, in the real world, this would damage the tank. Can turn on the mixer, but apparently the mixer doesn't mix as long as there's no fluid. So let's turn that off. Let's put some mixture in the tank. Let's see if there's see what color the stuff is that comes out of pump 1. Okay, there we go. It's sort of a brownish color, tan. Now notice that this low level switch came on. This is an on-off switch. This is not sensing the height in the tank. It's just sensing whether or not there's anything at the bottom of the tank. So low level is true. Let's see what happens if I just keep filling. I think high level will go true at some point. Gotta be careful getting near the top. I've turned down the scan speed, you might notice. If you do this with the scan speed fully up, it fills the tank very, very quickly. So I wanted to be able to experiment with it. So there we go. So a high level switch comes on at a certain amount. It looks like there's just a little bit of space left in the tank. Let's just keep filling and see what happens. Oh, it pours out all over the floor. And then we get a warning about the product escaping into the plant. Okay, so then the simulation is reset. If you ever want to reset the simulation, hit simulators or simulations, reset simulation. Right now it's grayed out because we're in run mode, so you have to put it in program mode and then you can reset the simulation. But anyway, let's see what happens with the other pump. I've wired up the stop button to run the other pump. Oh, it looks the same. I guess it's supposed to be a different chemical, but looks the same to me. Okay, that's interesting. So can we get this stuff to leave? Let's try the enter button. Yeah, sure enough, there we go. Now notice that as I've been pressing these buttons and running these tanks, the lights on the left are flashing. So that indicates to me that those paddle wheel sensors do work the way I expected, and they're rotating and counting off volumes. Well, they're giving us a pulse, basically, every time one volume of liquid has gone through. And I don't know how many volumes it'll take to fill up this tank. We'll find out in just a minute. Let's do some other things, though. Let's put a little more fluid in here. We've got a thermostat over here, but it's an on-off type thing. It looks like it's set at 32 degrees, so I think it'll come on at 32 degrees, and I think it'll have the temperature in the tank will have to drop below probably 16 from 32. So let's change that. Well, it looks like we can't change the lower number. Okay. Well, I guess I'll just turn it to 40. I didn't like the 32. That makes it difficult to understand. So I think the way this thermostat will work is that at 40 degrees the switch will come on, and I think that once the temperature drops down, let's see, 40 minus 16 would be what, 24? I think once the temperature drops below 24, then this thermostat will go off. So I think this is a thermostat switch with hysteresis. Let's find out. Let's turn on the mixer. Yep, mixer works now. Good. Let's turn on the heater. So there we go. Temperature is going up very quickly. When we hit 40, I think that, yep, temperature switch comes on. I accidentally went to mixing. Now let's see. So you'll notice we're at 41 degrees. It's going down too slowly for my taste, so I'm going to let some of the liquid go out. Let's see how good this simulator is. Makes sense that the temperature would still be the same. What if we dilute it? Yeah, as I add more fluid, pardon me, as I add more fluid, the temperature drops, so that makes sense. What I didn't expect, though, I expected it to take I expected it to take a drop all the way to 24 degrees, and maybe it did and I missed it. I don't know. I'm going to put a whole lot of liquid in the tank. Maybe not quite that much. There we go. And now I'm going to heat it up so that the thermostat comes on. We're almost there. There we go. Okay, so we're at 41.2 degrees, slowly losing heat. So the temperature is slowly going down. All right, let's wait and see. Let's see, this is going to take a while. How about if I add just a little bit? Yeah, that makes it go down pretty rapidly. Now we're at 40.2. I just added a little bit of fluid. We're at 40.1, 40.0, 39.9, okay. So actually that wasn't the hysteresis, that's the current temperature. So this is the switch temperature, and that is, let's see, I guess if I'd hovered above it, it would have told me. There's set point, and it's not going to tell me that that's the temperature readout, but that makes more sense now. Now notice there is some hysteresis. How much was there? Let's see. Let's get rid of some of the fluid, and we'll add just a little bit till we get to, there we go, we're at 40 degrees. 39.9, so there's 1/10 of a degree of hysteresis so far, 2/10. Okay, so at about 2/10 or 3/10 of a degree, the switch turns back off. So now we know those points. Okay, so I think we understand enough about the simulator to program it. Now let's make up a recipe. I think I already made one, but oh, there's one more thing to do. We have to figure out how many ticks of the flow meter represent a full tank. So let's drain the tank. In fact, I'll just reset the simulation. I'm going to go into program mode, and I'm going to add in a counter. So let's get a new rung. Let's put a counter on that rung. CTU is count up, CTD is count down. I want to count up. I have to use a particular counter number. I'm going to use C:0. And these counters are a whole lot like the timers. If you understand or have seen the timers in this language, in this Allen Bradley Rockwell automation language, you know that the timers have an enable bit, timer timing, and a done bit, as well as a preset word and an accumulated word. So these two are 16-bit numbers, whereas each one of these other three first things with slashes are bits. The counters are a lot like timers, except that counters count events, whereas timers count up time. So the counters have a couple of bits. One of them is the count up bit, and what that means is just that the counter is currently counting up. There's also a count down bit, and when that bit is on, which the counter turns on and off automatically, the counter controls these bits for you so you can read them. When that bit turns on, that means the counter is counting down, it's decrementing. Done means that there's a comparison being made between the preset and the accumulated value, and the accumulated value is at the preset. In other words, let's say I want to count 10 objects, right? So I set the preset to 10. Now if it were updated, you'd see it here. Let me open it back up and it should be updated. Yeah, now the preset is 10. Once I have false to true transitions, once I have 10 false to true transitions on this line, the counter will be triggered 10 times. That's a triggering of the counter, is a false to true transition on the line. And so once the accumulated value reaches 10, then the accumulated value is equal to the preset, and then the done bit will come on automatically by the counter. OV is overflow. That's a bit that if you count, I don't remember if it's if you count the accumulated value above the preset or if you, I think it's when the accumulated value runs back around, because the accumulated value, this .acc, is only 16 bits. So if you get all the way up to 65535 and there's one more trigger on the line to make the counter count up, it'll have to roll back to 0. So I'm pretty sure that's when the overflow bit comes on. UN, I don't remember, I don't use it. So what I really want to do is just count ticks. So let's just take input 5, and I guess I'll just copy it and paste left. That way I'll still see its light flashing and know that it's working. But basically what this flow meter is going to do is it's just going to give me pulses, false to true transitions, right? A rising edge. Those are all the same thing, in order to trigger this counter so that the accumulated value will increment. So let's see, let's reset the simulation, that way we clear out the tank. I thought it would clear out the tank. I guess not. Download and run. Oh, there we go. Okay. So let's see. I'm going to put some stuff in the tank, and I think what will happen, yeah, my counter is counting up transitions of that flow meter. If I were to press the stop button and put fluid in the tank with pump 2, I'd throw my count off because the counter is only counting pulses from flow meter 1. So let me not do that. I'll try to fill this tank and see at what level of counts the high level switch turns on. We're at, let's see, it's hard to get just one count increment. We're at 290. I remember it was a little higher than this. We're at 300 counts. Okay, 301. Trying to just tap the mouse button to add just the smallest amount of liquid more. 303, 304, 305, 306. Okay, so at 306 ticks from the flow meter, that's when the tank is full. Let's try that with the other pump also. So let's go and add another. Well, you know what? Let's do it this way. Let's copy this rung and paste rung below. Then I don't need that extra rung. And instead of flow meter 1, I'll look at flow meter 2, which is input 6. And I will use a different counter. I'll use counter 1 for this. Now I don't care about the preset really. It doesn't matter. I'm just counting how much it takes to fill this tank. So run. I still have the ability to drain the tank, so I'll do that. Let's see. Notice I have no counts on flow meter 2, but I would like to see at what level the low level switch turns off, or on actually. Pardon me. Well, there's just the smallest amount of liquid in the tank right now, and the low level switch is still on. Let's see. I still see some brown. There we go. As soon as there was no brown, it turned off. All right, so let's just add the littlest bit. I'm going to try and get flow meter 2 to give me 1 count by tapping the mouse. A little too fast. There we go. So the low level switch comes on when 1 tick from flow meter 2 has arrived. In other words, 1 volume of fluid has arrived from pump 2. You can just barely see a very thin brown line. I don't know if it'll show up on the video, but I can see it here with the resolution on my monitor. So in other words, if there's anything at all in the tank, the low level switch comes on. That's good to know. And so now I'll fill up the tank and see if it takes the same number of counts to fill as when I was using pump 1. I think it will. Let's find out. We were at 300 and I think 5. There's 304. We'll just tap it. 305. Maybe it was 306. Oh. Took 307 this time. I don't know if that's a variation in the simulator or what, but I'm not going to worry about it. It's about 306, 307. So I would only fill the tank to about 300 units, and that would be the most. I wonder if when it's full, if activating the mixer will make things slosh out. No, apparently not. Okay. What about boiling over? We'll just heat up the stuff and see what happens. We'll see if we can overheat it. I don't know what temperature it would take to overheat this stuff. Looks like it's pretty resilient. I'm assuming that this reading is in Celsius. We're at 80 degrees, 90. Oh, it only goes, oh, there we go, 100. Due to vessel rupture caused by overheat. Okay. So we can make it go too high. We don't want to do that. All right. We're back in run mode. It's been reset for us. Let's put some stuff in the tank and let's pump it out. Let's see what happens when we pump everything out. And once it's gone, we just keep pumping. Okay, there's some kind of fire there. Let's see what happens. What does it tell us? Ah, plant shut down. Pump number 3 ran dry and overheated. Okay. So now we know what the simulator does and how it works. So now let's go and program it. And what we'll do is add 1 unit, let's say, of pump 1 to 2 units of pump 2. So I'm going to try and put in a total of 100 units from pump 1 and 200 units from pump 2. That'd be a total of 300 units. And then I'll mix them up for a certain amount of time, then I'll heat it to a certain temperature, mix at the end, and then pump it all out. So that's the sequence of events that I want to have happen. So let's see, I guess I'll just heat it up to the set point. Yeah, so now it's time to program. Now we're going to use something, a technique in this simulator called finish flags. The idea is that there's certain events that have to happen, and once those events have occurred, then it's time to move on to the next event. So we need to remember that events have occurred. So what we're going to do is use memory bits to remember that things have happened along the way.